Okay, I'm going to get us started on 7.4. This is a little bit too much to do in one video, so this is just going to help you get started. Chapter 7 is a little bit more in depth, and you really have a lot of numbers you're using with this. In statistics, there are a lot of numbers, and there are a lot of formulas, and I just want you to be able to take the formula and plug in your values. We have for this one we have a population with a mean. So the population mean is 250 and the population standard deviation is 35. Calculate the standard error of the mean for the following sample sizes. So we want the standard error of the mean. When you view your example, and when you take your exam, I will have the formulas that you will need for the exam available for you to use to print and bring with you. Recall that population standard deviation, this sigma sign, okay, is known as the standard error of the mean. So when we're talking about the standard error of the mean, we're talking about the population standard deviation. So what we do is we take the standard deviation and divide it by the square root of n. N is always your sample size. So if we look at our example for A, how did I get 7.83? First thing that you have to remember is that you're going to use your sample size, which is 35. So you're going to do 35 divided by the square root of n. Well, the square root of n is 20. So you take the square root of 20 and you do 35 divided by the square root of 20. And you will round that to 2 decimal places. So when you do that, you will get 7.83. For the next one, do the same thing. Take your standard deviation is still 35, so that's not going to change. You're going to take 35 divided by the square root of 50, and that is the standard error of the mean. Okay? And if you take a sample size of 80, you're going to do 35 is your standard deviation divided by the square root of 80, and the standard error of the mean is 3.91. Notice, as a sample size increases, it's more representative of the population the bigger your sample size is. Notice what happens for the standard error. The error is going down. Your data value is becoming more accurate because your sample size is increasing and it's more true to the actual population. Let's move on to question number 2. Okay, here, this is where we're getting to the table, the curve values, okay? Find a normal population with a mean equal to 74 and a standard deviation equal to 11, and determine the probability of observing a sample mean of 79 or less from a sample size of 12. Okay, so what we want to do is we need to calculate the standard error of the mean. Remember how to do that? We take the standard deviation, 11, divided by the square root of n, which is 12. 11 divided by the square root of 12. If you divide 11 by the square root of 12, you will get about 3.176. Okay, so the first thing is to find the standard error of the mean. Now, if you look at your example, we already know how to do this part. The new part is this formula here. Okay, X bar. That is the sample mean. This is called mu. This is your population mean. So you're going to take sample minus population divided by the standard error. That number I just told you, 3.464, will go down here. So what is our sample mean? says the sample mean is 79 and the population mean is 74. So you're going to do 79 minus 74 and divide it by 3.176. And when you do that, you're going to get a number, the number 1.57. Now, it is going to be negative. Actually, it's going to be positive because the sample 79 minus 74 is 5. So it's going to be positive 1.57. So we want to find, notice these numbers are negative over here, your z-value. So we need to go to the positive. How do you read this table? Well, you start over here and you go to 1.5. Now, if you scroll back up, the first value is 1.51, 1.5, 1.50, 1.51, 1.52, 1.53, 1.54, 1.55, 1.56, 1.57. So, if you want it to be less than or equal to this number, when you look up 1.57, the probability is all of the probability under this curve less than or equal to. So we're good with this number that we get when we go to 1.57. It is 0.9418. Now, if it asks you for the probability that it is greater than or equal to, the whole probability should add up to 1. Okay, so if 0.9418, the probability of your value being here or less is 0.9418. If you wanted to find the probability of it being greater than this value that you just looked up, you would take the number 1 and subtract out the probability of all of this. So if it asks you for it to be x is greater than or equal to 79, you would say 1 minus this number. But since it's less than or equal to, that's the value that we're giving. So there's no subtraction required. So remember, the area under the curve is what's in the table, okay? When you look your z-value up and get your probability, that is the area that number is, that is the probability that it's that number or less. If you want to know the probability of it being greater than that number, you have to take the number in the table and say 1 minus that number. Okay, we'll look at one more. I'm going to break this video up into sections. Okay, so here for a population that is less skewed with a mean of 28, standard deviation of 14, and a sample mean of 25 or more, observing a sample mean of 25 or more from a sample size of 36. Okay, so the population mean is 28, standard deviation is 14. Okay, we want to find this, the probability of observing 25 or more. So here's that more thing that I was telling you about. Our sample size is actually 36. Remember, sample size is n. So you're going to take 14, find your standard error of mean, 14 divided by the square root of 36. Well, the square root of 36 is 6. 14 divided by 6 is going to be approximately 2.33. That is your standard error of your mean. Now, to get to the table, we can't just stop there. We have to keep going. That's your first formula. Remember, the second formula to get your z-value is your sample mean minus your population mean divided by standard error. We just calculated the standard error and it was 2.33. So let's look and see again what our sample mean is. Our sample mean is 25 minus 28. So 25 minus 28 would be negative 3 divided by the standard error we said was 2.33. So if you divide negative 3 by 233, you get negative 1.29. So we know this first table is our negative number. So we need to go to negative 1.29. And the 9 value is the last value. So 0.0985 would be everything to the left of that, but we want greater than or equal to. So we have to take what we get in this table. It was negative 1.29, and it's so easy to forget what the value was. 0.0985. Okay, that is the value of here over. So we need to take 1 minus that number, 1 minus 0.0985, and that would tell me what's left that's greater than, and that's how you get 0.9015. Okay, I'm going to stop here, and hopefully this will get you started on how to calculate standard error of the mean and how to find your calculate your z value to go into your standardized normal table and to get your probability. And what we're doing is we're finding how probable is it that our mean would be 25 or more. Well, 0.90 is pretty probable. That means there is a good chance that our sample mean is going to be 25 or more because our population mean is 28. So the higher this is, the closer it is to 1, the more likely it would probably occur.